we have written. Just I tried to show that in the fluid machinery part, what I told you is that impact of jets, and the second thing is that what is told to us to study is turbines part, and this turbine is further classified into one is impulse turbine. We'll study these topics. What impulse turbine, and second one is reaction turbine. Okay, impulse turbine and reaction turbine. Okay, so what is the job of these fluid machines? Like these are the machines. So machines, these can do two kind of works. One is that suppose your fluid which you supply to these machines are having higher energy, right? So what it will do is that it will extract energy from that and produce some work. So it is what it is called work producing devices. And sometimes there are machines like pumps we have heard, right? Like what I am trying to do now is that there will be a machine. I'll be supplying some energy input to it. Then what it will do possibly is that it will lift or it will increase the energy level of my fluid. This is simple, like in simple words if you want to understand. Then this is called pump. This is called pump. And work producing devices means that you were having higher energy, your fluid was already at higher energy, and then you supplied this higher energy fluid to someone to or what you did is that you supplied this higher energy to the turbine, and this turbine now will produce some work, and then it will get into the reservoir, another reservoir which is called sink. Got the idea? So this is the job of fluid machinery, or like machines. In simple words, if I say that it can do two kind of works. One is that it can produce work. How? It can extract the energy which was stored earlier into the water which was coming to that machine. And the second is that the I will supply some work to the that machine, and that machine will increase the energy level of my earlier fluid, right? Like the fluid whichever is coming to it, it will increase its energy level. Yeah. So hydraulic energy. So what happens in the turbines is that hydraulic energy is converted into what? Hydraulic energy is converted first into mechanical energy, and then this mechanical energy is converted into what? Electrical energy. Yeah, simple. Okay. So this is like the ideation part, like what is the job of fluid machinery. So let us next move to impact objects, as I said earlier. So what is impact objects? This you should try to write down in your copies also, because without this you will understand. And questions keep on coming from these areas also. Impact objects. Okay. Impact of object. Okay. Let us understand one by one. See, what is the impact object? That whenever a fluid, right, which comes out of a nozzle, so it has certain kind of kinetic energy, but all of the sudden this kinetic energy is going to change its form, right? Like it will, let us say that there was a nozzle, or let us say simple that this is that water jet. This is the water jet. Then this will come, and this is having kinetic energy, right? And this will come, and let us say that there was a plate which is fixed, and then it is hitting this plate. And what I can see is that this kinetic energy which was earlier with it, Now it is getting changed, right? So in that change, what happens that it is impinging force upon it. Then my job is to find out what is that amount of force which is being exerted upon it. Okay. Yeah. So force, what we know about force in our earlier school classes, we knew that force, what kind of force I am talking about here is, this is hydrodynamic force. Hydrodynamic force F. This is nothing but, whenever there is force, this will be nothing but the rate of change of momentum, right? Rate of change of momentum, yeah. Okay. So momentum. What is momentum? Momentum is nothing but mass times velocity. Yeah. And F, can I write down, this is nothing but the rate of change of this quantity. So can I write down it is d upon dt m into v? Yeah. So can I write down F is nothing but m into v2 minus v1 divided by t? And then can I write down F is m dot m upon t is mass flow rate per second into v2 minus v1. This is very, very important formula which is going to help us with this only formula will what will help you to find out force in your entire this fluid machinery topic. Okay, so this is very, very, very important. This is very, very, very important. And what is v2 and v1? See, whenever there is a strike, right, then it, let us say that it was coming out with the velocity v1. Let us say that there was a nozzle, and from this nozzle there was some water coming out. So this velocity was v1, and when it strikes this one, this is having another velocity. Let us say that that velocity is v2. What is this, we will talk about it later. But as of now, I know that there is one velocity with which it will be striking, and there is another velocity with which this fluid will leave this plate, right? So v1 and v2, these are those velocities. So this is the velocity with which this jet is leaving, and this is the velocity with which the jet is entering, and m dot is the mass flow rate per second. I hope till this point things are clear. Okay. So since force cannot like, we know that we are more or less worried about the magnitude part, right? So can I write down, this is force is nothing but m dot, that is mass flow rate, into v2 minus v1 mod. Why? Because I know that I am worried about what is the magnitude. Otherwise the sign will only tell you that okay, the what is the direction of force. But the direction of force is not that important here. Only thing is that what is the magnitude. Okay. So this is the force, like, this is the force, this is the force applied applied by applied by body over the fluid. And if I write F is m dot v1 minus v2, then this is the force applied by water over the fluid. Oh, sorry, by fluid, let us say by fluid over the body. Okay. Now, so if I am worried about that, particularly tell me what is the force in x direction. So can I write down fx is m dot? M dot will still be there, but can I write down, I am only worried about force applied by fluid over the body. force applied by fluid over the body. This is what I'm interested, right? I'm not interested in that what is the amount of force applied by body to the fluid. Why? Because by Newton's third law anyway they are same now. So I'm only worried about that what is the amount of force which water is able to, or in general fluid is able to apply, right? So in x direction, what I can write, that whatever is the mass flow rate, it times v1 in x direction minus v2 in x direction. Okay. Similarly, can I write down force in y direction is m dot into v1 in y direction minus v2 in y direction. Okay. Yeah. So what is 1 and 2? 1 and 2, I already told you that if this is the plate I'm talking about, then this fluid is entering here. So this is point 1 where it has entered, and this is point 2 where it has leave the body. Like what will happen? The water will strike and leave in this manner, right? So this is the velocity with which the fluid is leaving this wall. Okay, moving to the next. So let us this whole topic is summarized into number of cases, like that jet is coming from a nozzle, but your plate conditions might be different. Like the plate is fixed, the plate is moving, the plate is curved, or the plate is incline, or like that. The number of cases are there. So the important ones I will discuss here. First case is that when your mm, plate is stationary. So case one which I am going to study about is case 1. It says that the jet of water strikes flat stationary plate. Jet of water jet of water strikes flat stationary plate. Okay, so let us first try to draw a stationary plate is there. Okay, and upon this stationary plate means what? The plate is not moving. Then we have a nozzle, and from this nozzle there is a jet coming out. Okay, and then this jet is striking this plate and leaving in this manner. This is what I told you earlier also. So see, one thing I can see is that every jet has its own diameter. Can we appreciate that fact? Every jet has its own diameter d. Every jet has its own diameter d, and this is moving with the velocity v1, and unless it has strike someone, this velocity is to remain same. That means that from this point to this point velocity is v1 only, right? Yeah. Now the second thing is, can I see that the mass is leaving, and if the plate is symmetric, means the jet has strike symmetrically, then can I see that the mass is uh, not mass. Let us first decide the what about velocity. So let us say this is that velocity v2, and this is that velocity v2 with which the jet is leaving. Okay, and one more thing is that this is the part through which half of the mass will be leaving out, and this is the part through which half of the mass will be leaving out. Okay, so here what I have, the diameter d, velocity v1, and mass flow rate m dot. Okay, so now my task is to find out what is the force. Tell me what is the force. So in order to find out force, let us first try to find out force in the direction of x. So fx, just now we have seen that this is m dot into v1x minus v2x. Okay. So m dot is what? Mass flow rate, and mass flow rate is density times what? Discharge. And what is density? Is density is itself, and discharge is area times velocity. And how we will find out the jet area? This is the mass flow rate which this jet is carrying. So here Sorry. Sorry. So this A is the area, and what is this A? This is nothing but pi by 4 into d square, whatever the jet's diameter will be given to you in the question. So mass flow rate terms is fully solved. What is that mass flow rate? This is rho area times. Can I write down area only in order to avoid confusion? But I am again writing down here area is A is the jet area. What is this numerically? This is pi by 4 times d square. So can I write down this as rho A into V into V1x minus V2x? And what is V1 x value? V1. And tell me what is V2x value. See, there is no velocity in the x direction. Why? Because there is no fluid flow in the direction in which it was coming. Can we see that the all of the jet which were coming in this direction has now changed its direction completely into y? So can I write down V2x value as 0? So can I write down this one as rho A? This is V1 and this is also V1. So can I write down this one as rho A V1 square? So Fx means the force in x direction is rho A V1 square. I hope the things are clear. Okay. Now, what is the force in y direction? What is the force in y direction? Fy value. Fy value. Is there any mass flow rate in y direction? Is there any mass flow rate in y direction? And moreover, see, even if you are confused with the mass flow rate, can we see that there is half of the fluid living in this direction and half of the fluid living in this direction, and there is no velocity earlier in the y direction. Can we see that there is no velocity, there is no fluid which is entering in this direction, there is only fluid which is leaving in y direction is at the leaving point, there is no fluid which is entering in the y direction. So can I write down this one as m dot, and initially it is 0, right? There is no velocity in y direction, and in y direction at the exit point I can see is the what I can see is that half of living in this side and half is living in this side. So the final resultant will again become 0 only, means 0 minus, can I write down 0 minus m dot 1 is m dot v2 m dot by 2 into v2 minus m dot by 2 into v2. So this is anyway 0. Let me tell you again that what will be the value of fy. If I summarize, this is initially this is 0, and what is leaving is m dot into v2 by 2 in one direction and m dot into v2 by 2 in another direction. So this whole again becomes 0, so fy value is 0 anyway. And the second thing is what is work done, and work done is nothing but force times velocity, means power. If I say so, there is the plate is stationary, right? Like the plate is not moving. So if plate is stationary, if plate is stationary if plate is stationary, then the work done is 0. Okay, I hope things are simpler. Okay, so similarly we'll be having n number of cases like this one, and we'll have to determine that what is that force value. But first thing which I have told you, there are number of questions which have been asked in the gate exam in the very on the based on very first concept. So all of us should be aware of this fact. Okay, so initially what we have seen, what was the fx value? Rho a va square. This is very 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 important. We should star mark it and we should keep mind that how did we reach here. The formula means you need not to remember this formula, but you should know what was the concept behind this. Okay, so what was the force? Mass flow rate into change in velocity in that particular direction. So mass flow rate I knew, and what was the change I also knew, so I am done with that fact. Okay. Okay. Yes. So why Fy is zero? Because mass flow rate is not zero, but I have seen that V1 was zero, means V1 in y direction is zero, and V2 in y direction is the sum of these two. So that is why the whole terminology became zero. Okay. Moving to the next part, that how do we solve the other case if the plate is inclined. If the plate is inclined, like the plate was stationary, but now we are having second case. Case 2 is plate is stationary inclined plane. Stationary inclined plate. Okay. So now let us find out what are the forces upon this plate. So there is a plate, let us say this is that plate. This is that plate upon which let us say that there is a jet which is impinging upon it, and this angle with between these two is theta. Okay, so now my job is to find out what is the force in normal direction. What is the force in normal direction? Okay, why? Because if I know the force in normal direction, if I know this force in normal direction, then I can find out what is the moment of it. So in order to find out moment, so I need to find out what is the force in normal direction. So my job is to find out what is the force in normal direction. Again, same thing. The density is rho, area is A, and what is that? This is coming with the velocity v1, and second thing, mass flow rate I am writing down as m dot. Okay, so what will happen again? As soon as it strikes, the half of the velocity, half of the fluid will leave in this direction, and half of the fluid will leave in this direction. So this is v2, this is also v2. Okay, now, so what is the force in normal direction? Fn value. So in order to find out the force in normal direction, what is the normal to it? Like this is the normal direction, right? Fn means the this angle is 90 degree. Then I can say that this force is acting upon this plate in normal direction. Yes or no? Okay, so what is this Fn? Fn is again mass flow rate, and mass flow rate I have told you that this is rho a v1 and into what the velocity earlier. What is the velocity in normal direction? If this is the v1 value, then this is v1 cos theta, and normal velocity is v1 sin theta. So can I write down this one as v1 sin theta minus 0? Minus 0, why? Because there is no velocity in the what, in this direction we have no final velocity, right? The velocities are in these two directions. So can I write down this one as 0? So can I write down that Fn value, that is force in normal direction, is rho a v1 square sine theta. This Fn, this value is rho a v1 square sine theta. Now you can find out that what are the components in x and y direction. Can we find out what are the forces in x and y direction? So if this angle is theta, this is 90, so this angle is 90 minus theta. Yeah, so this angle is 90 minus theta. So the components of it will solve. So component of this Fn Fn cos whatever this angle is, cos 90 minus theta will give you what? The force in x direction, so can I write down fx value is fn times cos 90 minus theta. This is the x direction, right? This is x direction. So in this direction, fn cos 90 minus theta is acting upon it. So fx is fn cos 90 minus theta. So this is nothing but fn sine theta, and fn we have already seen that this is rho a v1 square, and sine theta into sine theta is sine square theta. Okay. Similarly, what is fy? Here the fy will not become directly 0. Here fy is giving you certain value, and what is that? fy fy is, can we see that this is in y direction? What is that component? This is in cos, this is cos component, and in y direction we'll be having what? Sine component. So fy is fn what? This is sine 90 minus theta, and sine 90 minus theta is cos theta. So can I directly write down this as fn cos theta, and this is fn value rho a v1 square. So can I write down this one as rho a v1 square sine theta into cos theta. So this is done, right? Okay, and fn. See, there is nothing which is required to be remembered, just the concept. If these things are in your mind, you can do. So only thing is that we should keep mind what was the concept behind the what derivation. So let us move to the case third. In this case, what we are going to do is that we are using this jet upon a curved plate. Okay, so the jet of water, and it is striking at the center of the curved plate. So jet of water here will strike upon the center of the curved plate. Okay, so can I write down the topic is jet of water strikes strikes at the center of a curved plate. Okay, so let us now assume there is a curved plate. Let us say, let us say that we are having a curved plate. This is that curved plate. Okay, so upon this curved plate, we'll be finding out what is the force. Okay, so the jet is being issued from a nozzle, and this is impinging at the center of this curved plate. So what happens is that this fluid will follow this curvature, and then from this part this will exit out, right? So this is the velocity with which this one is existing. Okay, and again this will be existing from this area. Okay, and what about the theta? So see, this is the deflection angle. Okay, so this is the deflection angle of this plate theta. This is the deflection angle theta. Okay, so this is the deflection. No, this is not deflection angle, this is the deflection angle. This is the angle of deflection of this plate. Angle of deflection of the plate. Usually this is more than degree. Can we see that if this was not more than 90-degree, then it would have been a flat plate, but this is the always most of the time this is more than 90-degree. Okay, now, so this angle will be given to us. So can we see that this theta and this thetas are same, this theta and this thetas are same, this theta and this theta is same. Let us say that this velocity was v1 and this is exiting with velocity v2, and this value is also v2. So can I see that in this direction we are having v2 cos theta, v2 cos theta, and in this direction we are having v2 sine theta, and in this direction similarly we are having v2 cos theta, and similarly we are having v2 sine theta. Okay, so our job is to find out what is the force. So first thing is mass flow rate. Mass flow rate is again rho a v1. The jet area is a, so the rho a v1. Now my job is to find out what is the force in x direction. So can I write down this one as, earlier we have seen this was m dot v2 minus v1. So I am just v1 minus v2. Okay, so I'm just expanding this term. So can I write down this one as m dot v1 minus m dot v2? So m dot v1, this part is given to us. Okay, so rho a v1 times this v1 minus now m dot into v2. So can I see that this mass is leaving from 2 points again. This is m dot 2 and m dot 2, m dot by 2, the mass, and m dot by 2 is leaving from this point. So m dot by 2 and m dot by 2. So can I write down this one as rho a v1 minus, can I write down now that, can I see that the v1 is in this direction, v1 is in this direction, but v2, with which this is the velocity in x direction, can I see that both of them are in negative direction? So can I write down this one as m dot by 2 into v2 cos theta, v2 cos theta, and again we have minus of m dot by 2. Why I am using these minus signs? Because we are having velocity opposite to the direction with which the in the opposite to the direction of entering velocity. So v2 cos theta, so m dot by 2 into v2 cos theta. So now can I write down the fx as, fx is rho a v1 square, rho a v1 square into, and moreover this v1 value will be equal to v2 value. How? This v1 value and v2 value will be equal to each other. Tell me why. Simple, because there is no loss of energy, right? So when there is no loss of energy, then the velocity will always remain same. See, whenever this velocity is needed to change, this velocity with which it was coming now, and if this is required to get changed, then what will happen? Then this will be not smooth. There will be friction losses in this plate. If the friction losses are not present there, then the velocity with which it strikes this one now, with the same velocity it will be exiting. That means v2, this value is equal to v1. Earlier I did not write v2 is equal to v1, but everywhere this v2 value is v1. Like here, what I said, that there is no friction losses means the plate is smooth, and if the plate is smooth, v2 is equal to v1, means with the velocity with it was coming, with the same velocity it will go outside. Similarly here also this v2 value will be equal to v1, this v2 value equal to v1, unless there is mentioned that there is some frictional losses. Okay, yeah, or they will say that the plate is not smooth. Okay, now, so from this one, can I take this v2 as v1 and common outside? So now this m dot is anyway row a v1, and this two are having the same sign. So this negative and negative means m dot v2 cos theta, and this m dot v2 cos theta minus m dot v2 cos theta, and the minus sign is already there, so I am writing down the final expression. This will look like rho a v1 square into 1 plus cos theta. Okay, similarly what will be fy? So initially we are having no fluid flow in the y direction, so directly 0, minus, now let us see that what are the means velocity and what is their direction. So what is the direction in this, the upper direction, the flow is going on the upper side, and this one in the downward side. So if I treat upper as the positive side, then this will be m dot by 2 into v2 sine theta, and this will be I am treating this one as negative because it is in the downward side. So m dot by 2, m dot by 2 into v2 sine theta. So can I see that these two are having equal magnitude but signs are different? So can I say that this one is again 0? So again we are not having any force in y direction, and since I said that this is a stationary stationary plate, so the work done will be equal to 0 only. Okay, next. Tell me first if you are getting these things or not. I hope all of us are getting. Simple, na? Yeah. Let us move forward. Now what I will do is that, see, this the same thing is applied to what, our turbine parts. So once we are known through these now, then we'll directly go and find out what is the force and look after the other aspects. So it is very important to understand that what, how do we calculate the force value and other things. Okay, now the three cases we have seen now. So the another case is fourth case is, in this case what we are going to do is that we'll apply this jet in tangential direction, like we'll be having case 4, and this case 4 is case 4. This says that the jet of water, what is this case, the jet of water, this strikes to a vein, jet of water strikes to a vein in tangential direction. And what is this vein? This vein is again stationary. And how does it strike? In tangential direction. In what direction? In tangential direction. Okay, let us see what happens. So let us first draw what, a curved plate, and now the water is striking tangentially. Now the water is striking tangentially, that means the velocity is in this direction. This is the direction of velocity with which it is attacking this plate, and this is the direction with which it will be leaving. This is the direction with which it is leaving. This is V2. But if the plate is smooth, then V2 is equal to V1. Okay. Again, now let us say that this curve is not symmetric. Then what happens that this is having two different, uh, what do I say, that the angle of inclination. So let me say that what I am trying to say is that V1 is striking with the angle theta. V1 is striking with the angle theta, and this is leaving with the velocity with the angle of phi. So can you see that which angle is theta and which angle is phi? So if I draw a tangent in this direction, so can I say that this is theta? This is theta, and similarly, uh, I hope you understand that what I am trying to do. This is phi. This is phi. Okay. And what is the angle of deflection now? The angle of deflection now is this part. This part. This is the angle of deflection. If I if I say I'm sorry. If I say this is delta, so this is equal to 180 degree minus of theta plus phi. Minus of theta plus phi. Okay. Now will we have required to find out what are the force direction, what are the magnitude of forces. So in x direction, this is v1 cos theta. In x direction, this is v1 cos theta, and in y direction, this is v1 sin theta. Similarly, in the x direction, this is v1 cos phi, v1 cos phi, and in y direction, we are having v1 what, sine phi. This is also phi only, phi. Okay, so can I write down now what is the mass flow rate first? Mass flow rate is nothing but again rho a v1. But now what is the force? What is the force? Fx. Fx is, this is again mass flow rate into change in velocities. Okay, so mass flow rate is again rho a v1. But what is the change in velocity in x direction? In x direction, v1 cos theta is in this direction, and can I see that this is v2? So v1 cos phi means v2 is okay. Let me write down this one as v2 only, so you are not confused. But I am again writing down v2 is v1 here. Okay, so can I see that this is v2 cos phi? Can I see that this is v2 cos phi? So rho a v1 into this is v2 cos phi, and v2 is equal to v1. So v2 cos phi, no, why v2 cos phi first? V1 minus v2 na. So this is v1 cos theta, v1 cos theta minus of minus of, this is in opposite to the direction of this one. So can I treat this one as negative? So can I write down this one as v2 cos phi? So now my fx value is rho a v1 into v1 cos theta, v1 cos theta plus v2 cos phi. Again v2 is v1 na. So if you take v1 as common, so can I write down rho a v1 square into cos theta plus cos phi? Very simple. This is the force in x direction, and now tell me what is the force in y direction. Simple. Again, what I will do is that, what is the force in y direction? Here we are having initially the mass flow rate in the y direction also. Yes. So this is the first time we can see that we are having the at the entering, we can see that there is some mass flow rate. So again, what is this velocity, mass flow rate? Rho a v1, but entering fluid velocity is v1 sine theta. So can I write down this one as v1 sine theta minus of, this is v2 sine phi, and these two are in same direction, so there is no need to change the sign, and v2 is also equal to v1, so this is v1 sine phi. So can I write down this one as finally as rho a v1 square into sine theta minus sine phi. Simple. Now, again, there will be no work done. Why? Because your plate is still stationary. Okay. So now we'll slowly move to those parts where your plates are moving. Okay. So first instance where I am moving the plate, this is your case 5, where I am moving the plate. So what happens in this one is jet of water. Here in this one, the jet of water, this will strike, jet of water strikes, jet of water, this is striking, strikes moving flat plate. Earlier what did I do is that the plates were stationary, but now the plates are moving, so moving flat plate. Okay, so let us solve this part. So now we are having a flat plate, and this is also moving, means as soon as your fluid comes into picture, this is, or before coming into that, like your fluid is, your plate is having some velocity. So now what happens is that the fluid which will come into contact will not come into contact with absolute velocity, but now it will come into contact with what? Relative velocity. This is very easy to understand, that if the plate was stationary, then only I could have striked it with my original velocity, but since this plate is not stationary, then what is the amount of mass it is striking to it will be the relative velocity. Yes or no? With that relative velocity, so here mass flow rate, we can star mark the one thing, or we can note this one thing, that if the veins are moving or the plates are moving, then we are calculating the mass flow rate is calculated, rate mass flow rate is calculated calculated on the basis of, on the basis of what? Relative velocity. Simple. Let us try to solve what happens into this one. See, now here only we can do. So can we see that now your fluid was initially coming with the velocity v1. So let us say that this is the velocity v1. Okay, and what happened is that your jet was all, no, sorry, not jet, your plate was moving with the velocity u in the same direction, it was moving with the velocity u, but the magnitude being smaller than the velocity v1. So this is that velocity u, with which the blade was moving. So now, what is that relative velocity? V1 minus u, and this is called VR1. The relative velocity concept, I hope all of us know. So this is that relative velocity VR1 with which the fluid is striking to it. Okay, and this plate is moving with the constant velocity, that is u is equal to u1 is equal to u2. Means initially if the plate was moving with u1 and then the plate velocity has not changed, means the u1 and u2 both are same. Okay, and now the what is the relative velocity vr1, and this vr1 is nothing but v minus u1. Okay, so now the see the vector concept v1, can I write down v1 is u1 plus vr1 here? If you can see v1 is u1 plus vr1, write down, we can write. Okay, so what is the mass flow rate? Mass flow rate, I told you that now we will calculate on the basis of relative velocity. So can I write down this one as rho a vr1, and what is rho is still a, but the vr1 has been changed, means this velocity is not v, now this is v1 minus u1. So can I write down, see mod I am using because I mean to say is that the magnitude of this one. So can I write down now that what is the force in x direction? What is the force in x direction? This is the mass flow rate. Mass flow rate is rho a v1 minus u1, rho a v1 minus u1 multiplied by whom, v2 minus, sorry, v1 minus v2. And what is initial velocity v1? v1 minus u1, this is the velocity with which the fluid is coming to the this point, and in the y direction it is 0. Okay, so can I write down this one as rho a v1 minus u1 whole square? This is the fx value. Similarly, we have seen that in the earlier cases that there is mass flow rate, no mass flow rate entering in y direction, and equal in both of the directions. So fy is again 0. So now here we will be having work done. And what is that work done? This is force time velocity, and force times velocity. So I know that work done we are getting in x direction. So this is force, and force in x direction is rho a v1 minus u1 square. And what is this velocity v? This is the velocity of the plate with which the plate is moving. So can I multiply it by u? So now my work done formula is rho a v1 minus u1 square multiplied by u. This is important. Okay, now next. Similarly, if this was the case for inclined plate, this is not that important. So let us quickly do that. If the plate is inclined and this is moving also, so same thing, nothing to be done in extra. The same thing is that only we need to apply the concept of relative velocity. Let us say that this is the direction of jet in which this the jet is striking to it. This is theta, and this plate is moving in what, u, with the u velocity. So now again we should, u is in this direction, u is in this direction. So u is equal to u1 is equal to u2, means the entering and exit u's are same. U is the u with the velocity of plate. Okay, now so theta, this is again what I will do is that I know what is v1. V1, this is the velocity with which it was striking, and this was the direction of what, This is the direction in which the plate is moving, so this is v1 and this is u1. So this is that remaining part which is called vr1. So can I write down this one as vr1, means the relative velocity, initial relative velocity. Okay, so how do I write down what is that force? So force in normal direction first, and before that, what is mass flow rate? Mass flow rate is again rho times area into relative velocity, and this is v1 minus u1. Okay, now what is force in normal direction? So can I write down force in normal direction? This is that force in normal direction, fn. Let me change the color so that you know where is fn. So this is that fn. Okay, so this Fn value will be what? Rho a v1 minus u1, rho a v1 minus u1 multiplied by what? Multiplied by this component v1 u1. I told you earlier also that the component in this direction, this is cos component and this is sine component. So can I write down v1 minus u1 multiplied by sine theta? Sine theta, and there is no fluid velocity in normal direction at the exit. Why? Because the velocities are in this direction, so this is 0. So can I write down that fn value as this one as rho a v1 minus u1 square sine theta? This is fn value. Okay, so what is the force in x direction? So can I write down now fx? This fx is the sine, what, sine component. Yes, earlier we have seen it was sine component. So can I write down directly that this is 90 minus theta, right? 90 minus theta. So now I am trying to find out what is fx, so the cos component of it, sorry, sine component, right? So this is rho a v1 minus u1 square sine square theta, and similarly what will be fy, the cos component of fn. So can I write down rho a v1 minus u1 square into sine theta cos theta? So this is fx and fy. So now what is work done? And this work done is work done per second. Work done per second. Okay. So this is everywhere what I have tried to find out. This is work done per second. Work done per second. Okay. Nowhere this is only work done. Otherwise, we'll have to find out what is the displacement. But work done per second means the power. Yeah. So this is again force times velocity. And what is force in x direction? Rho a v1 minus u1 square sine square theta, and u is the velocity in velocity of what? Velocity of plate. This is the velocity of plate. Okay, moving to the final cases, which is the important with respect to what? Turbines part, and then we are done. Which is important with respect to turbine part, and then we are done. So now from this point onwards, the case which I am dealing now, this is very important when we are solving the problems of turbines. So from this part they may ask you the impact objects problem, and you will be able to solve. But now the next which I am going to teach you is those parts which is directly used into turbines. Okay, so let me write down what is that case number. This might be 6 or 7. This was 5, right? So this is case 6 and this is case 7. Okay, so what is this case? Let us discuss. So again we'll be having a curved plate. But now this plate is also moving with the velocity what? V, sorry, u. So now we are having velocity v1 with which the fluid is attacking this one centrally. So this is v1, and we are having the velocity u1 which is in this direction. So this is that u1. So this v1 we know, and this is u1, this we also know. So v1 and u1 when we know, then this is vr1. Okay, so v1, u1 and vr1 we know. Okay, now so this is the direction in which the fluid is coming out. Okay, so this is that v2, this is that v2. But again, if the plate is smooth, but now this will not leave with v2 only, but this will leave to with vr2. Getting the idea? This is vr1. So with vr1 this is entering now, so this will exit out with vr2. If this was the simple case, the plate was not moving, then this v1, and then this is exiting with the this simple velocity, that is absolute velocity v1 and v2. But now it will enter with respect with what, relative velocity, and it will exit out with relative velocity only. So this is vr2 and this is also vr2. I hope you appreciate this fact. Okay, so again this is theta, this is also theta, this is also theta. Why? Because this is the deflection which is equal. Okay, so this is that deflection angle delta. Okay, so this is theta and this is also theta, so delta is 180 minus theta. Yeah, now so this is vr2 and vr2. Okay, so first thing is, what is mass flow
You are
rate?
currently the only person in this conference.
What is mass flow rate? What is mass flow rate? Mass flow rate m dot is again density times area and initial relative velocity. So what is that? v1 minus u1. vr1 is v1 minus u1, just now we have seen in the case of stationary. So this is v1 minus u1, first thing. Okay, and then what is fx, force in x direction, is
You are
rho
currently the
a,
only person in this conference.
rho a v1 minus u1, that is mass flow rate. Mass flow rate multiplied by change in velocity. So can I write down this one as, initially this is v1 minus u1, this is the velocity with which the jet is striking. Yeah, so v1 minus u1 minus of, can I write down vr2. So what is the velocity in x direction? The component of vr2, and that too is
You
in
are currently
negative
the only
direction.
person in this conference.
That too in the negative direction. Why I can see that there is frequent your internet connection is not good. Okay, connection issue. Yeah, I understand. Okay, fine. Let me continue. Yeah. So this is v1 minus u1, initially v1 minus u1, but in the while exiting, what is that? We this vr2 cos theta, right? And vr2 I already told you is vr1, and vr2 is, if vr2 is vr1, then v1 minus u1 is, means vr2 is equal to vr1, and this is v1 minus u1, unless they mention that this plate is not smooth. Okay, so v2 is minus of v1 minus u1 cos theta. This component, this is that component, this is vr2 cos theta in x direction. Okay, so vr2 cos theta in x direction, cos theta. So can I write down this one as finally as rho a v1 minus
You are
u1
currently the
square,
only person in this conference.
v1 minus u1 square into 1 plus cos theta, into 1 plus cos theta. This is very important. Fx is this value. And again, same case, the same mass flow rate in this direction and this direction as well. So these two, see what is the physical meaning, these two effects of these two will cancel out each other. Okay, so fy is directly 0. So again, if I try to find out what is work done per second, so work done per second will be force times velocity, force times velocity. And in force in x direction I already know, this is rho a v1 minus u1 square into 1 plus cos theta multiplied by u. Okay, now, so what is the unit of this one? This is nothing but watts. What is the unit? Watt. Why? Force is, we know how to calculate. This is Newton and this is meter per second. Newton meter is joule and joule per second is watts. Okay, so the unit is in watts. Right now, so can I am be able to find out what is the this value, work done per second, work done per second divided by weight of fluid striking the vein per second. So weight of fluid divided by weight of fluid 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 strikes per second, strikes, weight of fluid which strikes veins per second. So this value is again rho a v1 minus u1 square into 1 plus cos theta multiplied by u divided by what is the weight? Weight is nothing but m dot g, right? So m dot, we know that this is rho a, capital A we have used now. So okay, rho a v1 minus u1 multiplied by G. So can you see that this is V1 minus U1 into 1 plus cos theta into U by G. Okay. So what will be the unit? Let us solve. So this is meter per second and this is also meter per second and this is meter per second square. So second square got cancelled, meter got cancelled. So this is in meter. So I will tell you the physical significance of this one later, but as of now you just appreciate this. Okay. Now, if the jet of waters, this is again important. This case, and the case which I am dealing next is these two are very very important. Okay, so let us study that. The case is case number. This might be, this is 7 now, so this is 8. So in this case, what I can do? Again, we are having a vein. Okay, so now again the fluid will strike and all other things. So first thing is that the with the velocity v1 this will strike, but there is velocity u also with which this what this plate is also moving. So what is this case? Jet of water strikes moving curved blade, moving curved blade in tangential direction. Okay, so this is V1, this is U1, this is V1, this is U1. So what is the relative velocity? The relative velocity is, we know, I told you na, that V1 is U1 plus VR1. So if this is V1, this is U1, then this is VR1, right? This is VR1. Okay. And this is angle alpha. I will tell you what are these things. Okay. And VR1 is, this is the angle theta, and this is VF1. Okay, and this V1 cos alpha, this value is VW1. I will tell you about all these things. Okay, similarly at the exit, let me erase this part so that I can draw this angle. These are called velocity triangles. Okay, we'll revisit it again, but as of now let us start studying it. Okay, so now VR1 is here. So the fluid will be exiting with what velocity? VR2. VR2 again. We we knew that V is the sum of VR2 and U2. Like V is the sum of U and relative velocity. So this is VR2. So this is U. This is U. Then this is V2, right? If this is U, then this is V2. Okay, and then we have flow velocity vf2, and we have world component of this velocity vw2. Okay, got the point?
Now unmuted.
All okay?
Now
All
unmuted.
okay?
Sir, I think V2 will be outside and V F2 will be inside.
What did you say? No, 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 why v2? Why I can hear my own voice? I don't know why I was hearing my own voice, and now this is sorted. Okay, see, this is this is the velocity v1 I'm drawing here. This whole triangle I am drawing out here, so your doubt will be resolved. See, velocity will be living with what? Will be living with the relative velocity, right? That is v2, sorry, vr2. So this vr2, I already told you, this is nothing but the relative velocity, which is the relative velocity, which is the sum of whom? Sum of uh, initial velocity v1 and the sum of second thing, that is u, which with which the plate is moving. So I am again drawing that triangle here, this triangle. Let us look after. This is the vr2 with which vr2 with which the fluid is moving. Okay, vr2. Now we are having u2, we are having u2. So this is that V2. This is that V2. Okay. And this V2 have two components. Okay. So this angle usually we call it phi, and this angle we usually call it beta. I will tell you about every single thing. So this is phi, and this between this v2 and this direction, tangential direction, this is the angle beta. So now this v2 will be having two components. One is this direction, so this is called vf2, flow velocity, and this is that tangential velocity vw2. Tell me if you have any doubt in this triangle.
Now unmuted.
Clear, sir, clear.
Okay, so please mute yourself again so that I don't hear my voice again and again. Yeah, this is done. Okay. See, only thing you remember is this is V1 with which this fluid is entering, and then we are having U1, and then the sum of these two means U1 and VR1. The resultant is V1. Okay. U1, and this is VR1, and this again this fluid velocity V1, this is having two components. One is flow velocity and another is world velocity or tangential velocity. Yes or no? This is the velocity. This VW1, if I say, this is the tangential component of velocity V1. Yes or no? This is the tangential component of velocity V1. So let us first draw one more thing, that theta and beta concept we have already seen, right? So let me draw it again. So this is that angle theta, and here this is that angle phi, this is that angle phi, and this is that angle of deflection, that is delta. This is 180 minus of theta plus phi. Okay. Now, so what are these angles? So alpha, which I told you, is called nozzle angle. Nozzle angle. So my problem is someone will state me in the question that the nozzle angle is this one. So you should immediately understand. We'll say that nozzle angle at the inlet. That means he's asking about which angle? This angle. Okay. So alpha is the nozzle angle. Similarly, theta we have seen now. So theta is called vane angle at entry. Vane angle at entry. Why this is called so? Because this is the angle theta, this is what angle through which this velocity, through which this fluid is entering or hitting this curved vein. Yes or no? This is the velocity with which this jet is hitting this curved vein. So this angle theta which it is making is called what? Vein angle at entry. Okay. Similarly, what is phi? Phi is the vane angle at exit. Vane angle at exit. And another one is beta. Beta. So this is the angle. This is the angle between whom? V2 and U2. Got the idea? Everything? So there is no specific name to this one. So that is why I have written that angle between V2 and U2. So what is this called? Angle between the absolute velocity at the exit and the what? The velocity of plate, right? So if this is again, if it is says that this is a smooth vein, whenever they say smooth vein, that means that there is no friction losses. That means VR1 value will be equal to VR2. Now, if they will say this is a rough vein, if they will say rough vein, then what will happen that vr2 value this will be lesser to vr1. So vr2 I will write is k times vr1, and this k will be nothing but coefficient of friction. Coefficient of friction. Okay. Now, so v1, this is absolute velocity of jet at entry. Absolute velocity of jet at entry. And what is v2? v2 is absolute velocity of jet at exit. Absolute velocity of jet at exit. What is vr1? vr1 is relative velocity of jet at entry. Relative velocity of jet at entry. What is vr2 is relative velocity of jet at exit. More the important parts is being written here. What is vwn? Vw1, this is called tangential component of absolute velocity. Never forget what was this component. Tangential component 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 of whom? Of absolute velocity. Tangential component of absolute velocity. Okay. Absolute velocity of jet at entry, or we can say that this is velocity of entry, velocity of world at entry. Okay. Similarly, what is vf1? vf1 is called radial component of radial radial component of absolute velocity of jet at entry, or what do we say it? This is the velocity of flow. Velocity of flow. See, this is that component velocity of flow. This is the component which is responsible for the what is the amount of fluid will be entering in this direction, yes or no? So that this is very very important concept, that vf1, this is the component responsible for the amount of fluid which will be entering into this plate. So whenever we are told to find out what is the mass flow rate or the discharge through that vein, so which velocity will be directly jumping to is the flow velocity of flow. And what is vw2 and v of 2? vw2 and vf2 are nothing but these components at the exit. Same thing vw, you understood na? So at exit, and this is again at exit. So I'm not writing those whole thing again, so I hope you understand what do I mean. Okay. Okay. So this is important that you draw these things on your copy, so that this is will not have to go back on this side again. So please draw this triangle. If you have not drawn, please draw this triangle. This is clear to you now, or this is ambiguous? Any ambiguity you can see? I hope this is clear. Okay, so please draw that one. Or is it ambiguous? Means you are not able to draw. Okay. Okay, so please draw that in your copy. So now, because I will be directly telling you that this is that component and all. So first thing is what is mass flow rate? This is m dot is rho a vr1. We have seen now. So this is rho a vr1. So this can I write down? This is rho a vr1 is v1 minus u1. And what is force in x direction? Fx. This is again mass flow rate into v1 minus v2. And what is mass flow rate? Rho a v1 minus u1, mass flow rate into what? Change in velocity. And what is that change in velocity? This is initial minus final. So what was the initial velocity in x direction? V1 cos alpha. And what was the initial velocity in final velocity in x direction? V2 V2 cos beta. Can you see? This is the velocity, tangential velocity. I told you na that we are calculating in x direction. So these velocity are nothing but tangential velocity. Yes or no? So the tangential component, nothing but tangential component. So now I am writing down this one as rho a v1. And what is v initial? V1 cos alpha. V1 cos alpha minus, can I write down this one as minus of v2 cos beta? So my fx value is rho a v1 minus u1, v1 minus u1 into v1 cos alpha is vw1, and v2 cos beta is vw2. Okay. And what is fy? Force in y. Similarly, what is the force in y direction? Is the mass flow rate times the velocity change in y direction. So can I write down this one as rho a v1 minus u1 multiplied by what is the initial velocity in y direction? V1 sine alpha. Look at or your copy, minus this is v2 sine beta, v2 sine beta. So can I write down this one as rho a v1 minus u1 into vf1 minus vf2. Okay, so now what is work done per second? Work done per second is force in x direction multiplied by u. So this is rho a v1 minus u1 into vw1 plus vw2 multiplied by u. Sorry, I'm having bad throat today. Okay, so can I write down this one as work done per second divided by weight of fluid, weight of fluid striking per second. So this is rho a v1 minus u1 into vw1 plus vw2 into u. This one we have just now we have seen, divided by m dot g. So can I write down this one as rho a v1 minus u1 into vw1 plus vw2 into u, divided by m dot is rho a v1 minus u1, rho a v1 minus u1 g. So can I write down this one as vw1 plus vw2 into U upon G. Yes, we can write down. Okay, moving to the next. So now we are moved to which case? This is your case number 9. See, if you know this one now, your fluid machinery is complete. I'm seriously telling you. If you understand these concepts now, the only thing is that draw the velocity triangle, understand the concepts that how flow is happening, and that is it. Okay. So this case which I'm writing down is jet of water. There will be jet of water. This jet of water strikes the flat plate, strikes the flat plate, strikes the flat plate mounted on a wheel, mounted on a wheel. So there is a wheel, and upon this wheel there are number of flat plates. These are the flat plates. Okay, so see, initially what we have seen, these curves plates are, these plates in fact are not mounted on any wheel. These were independent. Like we have seen the case of just one. What do I say? That just one plate was there. But if there is a series of plates, means these are mounted on a wheel. In that case, what we'll be seeing, I am discussing that one. Okay, initially what we have seen, those were individual plates, but now we are having number of plates. So this is that velocity v1, and we have initial velocity u1. So this is u1 and this is v1. So now what happens is that now there will be no mass flow rate which is relative. Why? Because as soon as one plate is gone, now another plate comes in. As soon as the another plate goes, the third comes in. So it will feel like that this is the case of that stationary one. Why? Because why there was change we could see is that every time the fluid is attacking it, this is moving in some direction. So in this particular case, what happens if there are a series of veins, means there are number of veins, then as soon as this one will move in this direction, the second will appear, the third will appear. So it will feel like that after some time, what you will feel that once it has taken its start, means once it has started running in full direction, full swing, then what you will feel is that every time this is moved to this direction, there is another one, another one, another one. So what it will feel like that this has gone nowhere, this is here all the time. So that means this is the case of stationary one only. Okay, so what will be the mass flow rate? This will be again rho a v1 only. See, the I am not writing down rho a vr1. Why? I told you. Okay, and u1 is equal to u2, and this is equal to pi dn by 60. Oh, this, see, I'm suffering some cold, I'm sorry for this. So this is u is pi dn upon 60. D we know, this we know, and d is the pitch diameter of wheel. What is d? D is the pitch diameter, pitch diameter of wheel. Pitch diameter of the wheel. So what is fx? Fx is again rho a v1, and what was the velocity with which it was coming to the plate? V1 minus u1 minus 0. See here v1 minus u1 is will be always there. Why? Because this is the velocity with which it is entering. But mass flow rate will not be relative. Why? Because there is number of plates. See the difference? The velocity with which it is attacking, it is still same, but the mass flow rate has changed. Why? Because there are series of veins. So now can I write down this one finally, that fx value is rho a v1 into v1 minus u1. Okay. And what about fy? This anyway will be 0 same again. So my problem is to find out what is work done per second. So can I write down this one as rho a rho a rho a v1 into v1 minus u1 multiplied by u1. Yes. And anyway u is same here also. So can I write down again what is the work done per second? Work done per second divided by weight of fluid, weight of weight of fluid strikes vein, which strikes vein per second. So this is equal to rho a v1 into v1 minus u1 multiplied by u divided by rho a v1 into z. So this is summarized as v1 minus u1 into u upon g. And there's no need to write down the u1 separately. This is anyway u only. So now my question is to find out what is the efficiency. What is the efficiency? So this is equal to work done per second, second by fluid over the plate, by fluid over plate divided by kinetic energy of fluid at inlet. That means total kinetic energy at inlet. So what is the work done per second? We have find out that this is rho a v1 minus u1 into u, and there is v1 also. So rho a v1 minus u into u divided by half of m dot va square. And what is m dot? M dot is rho a v1 and kinetic energy. So this is m dot. Total kinetic energy at inlet is half of m dot v1 square, means kinetic energy per second at the inlet. So half of m dot into v1 square. So this is rho a v1 already there and multiplied by v1 square. Okay. So can I see that rho a v1 is cancelled out. So can I see this is 2 times v1 minus u1 into u divided by v1 square. So sometimes it is asked that for the given v1, for given v1, what is neta max? What is neta max means what is the maximum efficiency? So this is d of neta upon du. Why? Because I told you that for the given v1, so when you will differentiate it, put it equal to 0. So this is v1 minus 2u is equal to 0. So can you see that v1 is 2u? So can I see that u is v1 by 2? One case is u is v1 by 2 for maximum efficiency, and when you put u is v1 by 2, your neta max will also turn out as 1 by 2, which is 50%. This is important. Many times we have been asked this question, that what is this u and what is this neta max. Okay, next. My next question is what is the force and other things when we are striking the curve plate mounted on a wheel. We have seen now the individual cases we have seen. So now we are mounting it on a wheel. So the jet of water, now your jet of water strikes at the center of vein, at the center of vein, at the center of vein, mounted mounted on a wheel. Okay, so what happens, there is a wheel, and then we have, okay, so which case is this one, center. So same thing, everything will remain same, only change which we'll see is that is the change in mass flow rate. So here again, the u is u1 is u2 is u is equal to pi dn by 60. And second thing is d and n, we know that speed in rpm of this wheel, and d is the diameter of this wheel. And first thing which we will experience is mass flow rate, that is rho a v1 again. Why I am telling you this one separately is that every time this will impinge some force upon it, the second volume come into picture, third one, and again. So this will remain same. So m dot is rho a v1. So what is fx? Fx is rho a v1 m dot, right? So this was v1 minus u1, minus initial minus final was minus of v1 minus u1. You can see in your copies, we have done this one. So can I write down this one as rho a v1 into v1 minus u1 into 1 plus cos theta x. Okay, and fy anyway is 0. Okay, so now what is work done per second? Work done per second, work done per second will be nothing but the same thing for fx into u, fx into u. And what is the fx value? Rho a v1 into v1 minus u1 into 1 plus cos theta multiplied by u. This we have seen. Okay, now this is again what we will try to do is that work done per second divided by weight of fluid strikes per second, weight of fluid strikes per second, then this is equal to rho a v1 into v1 minus u1 into 1 plus cos theta into u multiplied by weight of fluid is rho a v1 times g. So this is gone. Then what you can see is that this is v1 minus u1 into 1 plus cos theta into u divided by g. Okay, and what is the efficiency thing? Neta, this neta efficiency is again work done per second by fluid on vein divided by kinetic energy of the fluid at inlet, kinetic energy fluid of the fluid at inlet. So what is this work done per second is rho a v1 into v1 minus u1 into 1 plus cos theta into u divided by what is kinetic energy. This is half of m dot v square. and m dot we know that this is rho a v1 and v1 square. So the let us cut those things which can go out. So this is finally 2 times v1 minus u1 into 1 plus cos theta into u divided by v1 square. So again for given v1, again for given v1, for given v1, what I can see is that I will differentiate with this neta with respect to u. So then we will reach out to what? That when you will solve now, then you will find out again that u is v1 by 2 for maximum efficiency. Okay, so for maximum efficiency, the u relation, u the relationship between u and v. Okay, so you when you will put this one, your neta max will reduce to 1 plus cos theta upon 2. Okay, so if you put this theta, if you put the change in this theta, the neta max will change. Okay, so the neta max is 1 plus cos theta by 2. And what is this theta? We have seen this was the angle. I have told you already. Yes or no? Theta, I have told you, na, in case of curved plates. Yeah, this is that theta, this theta. Okay, now the one case and we are done. This is the last case and we are done with the impact of jets. So your case is case number 11. Case number 11. Let us understand this one. Now your jet of water will strike to wind in tangential direction, and this vane is mounted upon a wheel. This vane is mounted upon a wheel. So what is this case is jet of water jet of water strikes to a vane in tangential direction tangential direction tangential direction mounted on a wheel mounted on a wheel. So let us say that this is that this is that wheel, and we are having curved plates here. So now your jet is impinging upon it. Okay, so can you see that there can be two cases? One case is inner radial flow and another case is outward radial flow. Means what will happen that the fluid will enter, there is inner radial flow and this will come out. So this is called inward radial flow. Inward radial flow. One is inward radial flow. In inward radial flow will be, this is the wheel I'm talking about, this is the wheel, this is the wheel. So here we are having that velocity v1. So we knew that there was nozzle angle alpha. So now your fluid is entering and moving inwards, right? And there can be outward radial flow. What will be that outward radial flow? In outward radial flow, the fluid will start its travel from this point and will travel through the outside direction. That is it, no change. Okay. And here your u values will not be same. Why? Because here there is separate r and here we are having separate r. Got the idea? So here your u values are not same. If this is r1 and this is r2, we can directly see the difference between these two. Okay. And now we are having outward radial flow and we are having wings here. So in this case what happens? In this case what happens is the outward radial flow means the fluid will enter at this point and will go outside. Fluid will enter at this point and will go outside. So again, if this is r1, then this is r2. Okay. Now, so here your u1 will be pi d1 n by 60 and u2 will be pi t2 n by 60. Got the idea? And here your r1 value is not equal to r2, and with this case u1 is not equal to u2. U1 is not equal to U2. Similarly, same case, smooth vein, VR1 is VR2, non-smooth vein, VR2 is not equal to VR1. Okay. Now, here my job is to find out what is the runner power. Means if there is a if there is a runner upon which this wheel is attached and upon which there are number of vanes, then what is the power this runner will be receiving? So let us discuss that fact. Okay. So what I am having here is I have a vane. Okay. And upon this vein, what did I say? That the fluid is impinging tangentially. Yeah. So let us draw that also. So this is impinging upon it tangentially. Let us say that this velocity is v1 and the initial angle, nozzle angle, I told you that this is alpha, and we are having u value. So let us say that this is u1 and this is vr1. VR1. Then we have VF1, VF1, and this is VW. Not, no, no. This is theta, and this is VW2. This whole value is VW2. Yeah. At the exit, let us draw the velocity triangle. The velocity with which it exits is VR2, VR2, and then we are having U2, U2. Then we have velocity v2, this is u2, this is v2, and then we have this vf2, and here we have this is vw2, right? And this is vf2. This was phi and this is beta. Yeah. So what is d1 and d2 means, this vein is associated upon is upon a disk. Yes or no? I told you. So this value is, if I say this is d2, and at the entering point this value, this is d1. Okay. So very important part of this one is I'm going to discuss now that what is the runner power. Very, very, very important. What is runner power? My topic is to find out what is runner power. And with this one we'll end. And this is very, very, very important. If we understand this one, then most of our pain is gone. Okay. So runner power. What is runner power? Okay. So power, we know that this is torque times of omega. We know this fact now, torque times omega. So and what is torque? What is torque? Torque is rate of change in angular momentum. Rate of change in angular momentum. This we know. Yeah. And what is angular momentum? Angular momentum is moment of momentum. What is angular momentum? Angular momentum, this is change in linear or moment of linear momentum, I can say. Moment of linear momentum, right? Then, and what is linear momentum? Linear momentum, this is mass times velocity. And which velocity? Tangential velocity, yes or no? Which velocity? Tangential velocity. And what is angular momentum then? Angular momentum is moment of momentum. So this is m dot vw1 into r1. And this is I am writing down at entry, yes or no? At entry. Similarly, the same thing will be repeated at the exit also. So linear momentum at exit, linear momentum at exit. At exit, we can see that VW2 is in this direction, yes or no? VW2 is in this direction. Now V2 component is in this direction. So can I write down this one as negative? That this is minus of m dot VW2. Then angular momentum of jet per second, angular momentum. So this will be equal to minus of m dot into vw2 into r2. Yes. So what is torque now? Torque is rate of change of momentum. That means the difference between these two. And what is the torque at entry? M dot vw1 r1 minus of m dot vw2 r2. So this is what? M dot into, and this is minus now, so minus of m dot vw2 r2. So can I write down vw1 r1 plus vw2 r2? So now my runner power is torque times of omega. So can I write down this one as m dot into vw1 r1 into omega plus vw2 r2 times omega. Yes. And r times omega is nothing but the tangential velocity of the what? Disk, not fluid. So runner power, can I write down now finally, is m dot is rho times density times discharge rho q. Can I write down this one as u1? So vw1 u1 plus vw2 u2. This is very, very, very important formula. Very important. Sometimes these are directly asked in the exam. Okay. So based on this fact, if the direction of VW2 is not opposite, then the only thing which we need to do is that change the sign. That's it. Nothing else. Only thing you need to do is that change the sign. If the VW1 and VW2 are not in the are in the same direction, then there will be difference, and if in the opposite direction, it will be the sum of these two and nothing else. Okay. Okay. So let us finish this one with the finishing note, and then we'll start with the turbines in the next class. So once what happens that there is a vertical hanging plate. So questions might sometimes I have seen the question based on this case also. So your next case is case number 12. Your entire fluid machinery is based on the first today's class only. Okay, so in the next class onwards, I will be not explaining this much. I will directly say that okay, we know this. Yeah, so that is why we have spent so much of time here. So the jet of water, what is this case? Jet of water striking is striking vertical hanging hanging plate. Okay. So let us say that there is a vertical hanging plate. There is a vertical hanging plate, and upon which we have imposed some force. Yes. So this is moving in this direction. Okay. So now, can I do something here? Yes. So what is my idea to understand is my idea is to find out what is the force. Yeah. So let us do that. How we will do? See, here this plate is having some weight also. So this weight, this is that weight W. Okay. And at this point, this W is making this angle theta with respect to the axis of it. So this is theta, and this is the length of this plate L. This is the length of the plate L. Okay. So this is L by 2. This is L by 2, and this is also L by 2. This is also L by 2. Okay. So now let us try to find out what are the forces. So here your this is your Fn, right? So here what we'll be having when this plate has moved to some another direction. So here we are having Fn, and now since this was V1, so here this theta remains same, means this is that theta, so this is v1 cos theta, right? So Fn, and this is v1 cos theta. Now this whole is, let us say, y, and this is x. So can I write down y is x upon cos theta? Yes, I can. And weight of plate is mg. Weight of plate is mg, and L is the length of plate. L is the length of plate. Okay. And what is mass flow rate? M dot is okay. And what is normal force? Fn. Normal force is rho A V1 into what? V1 cos theta minus 0. This we know now, rho a v1 mass flow rate into normal force, normal component of this velocity. So this we know. Now, can I write down summation of moments at E is equal to 0 at the, where is my cursor? Here. So if I say that this is that end A, and since this is swinging about this end A, so can I write down that summation of moments at that point A is equal to 0. So can I write down now that F normal force into Y, this is that amount, right, is equal to W sine theta into L by 2. Where means this fn, this velocity which I have imposed upon it, means the fluid velocity, this can act from anywhere. So this case is generalized. So can I write down that if fn is, let us say that acting attacked at this point, means that the fluid jet is at this point, then this will become y, and similarly like that. Okay, so that is why I have converted y in terms of theta. So now can I write down fn into y is w by 2. This will anyway remain same. So now Fn value we have seen is rho a v1 square cos theta, and y we have seen is x upon cos theta, so is equal to w sine theta into L by 2. So can I write down this one is sine theta is equal to 2 times of rho a v1 square x upon mgl. So what is this theta? Theta is sine inverse 2 into rho a v1 square x upon mgl. Okay, so this is the final case. They will ask you to find out what is the theta with which this will deflect. Okay, so this is how we'll find out the angle of deflection. Okay, so your impact objects, which is the base of your fluid machinery, is done. So based on these facts, we'll continue in the other class. Okay, so please come revise with the notes, then only you will be able to cope up in the classroom. Okay, okay, then thank you. Good night.